Zachary Mueller, and today we're going to be talking about embracing literate programming without compromise, nbdev for collaborative projects. Now, who am I? As I mentioned before, my name is Zachary Mueller. I am a graduating senior at the University of West Florida, majoring in software design and development with minors in both computer science and environmental science. I am a very proactive open source contributor, with most of my development happening within the FastAI libraries. As mentioned also, I am a deep learning software engineer currently at nbdev Solutions, and I am the core maintainer currently of the Adapt NLP project, which is, as the name implies, a project that works with natural language processing. Now, what will we be talking about today? Before you is a general overview of how I view this presentation going. We're going to start with talking about what is this idea of literate programming, how do we integrate it with packages, the struggles that come along with it, some potential solutions, what we at nbdev have personally done, and where is the future heading. For those of you that are tech focused, there will be quite a bit of tech-centered discussion here. But for those of you that aren't, say like in management positions, a few of these key areas we'll talk about from a manager perspective. How do we care about this long term and sort of reduce that tech barrier in a way that's digestible for you guys as well. So first, let's talk with what is literate programming, because many of you might not be familiar with this idea. We have what I would call standard programming. And this is where we have segregated code, test, and documentation, each living in their own different folders. They're developed separately, and usually the programmers, or at least developer, has to spend some time making sure that everything's aligned. What comes with this is usually documentation gets put on the back burner or as an afterthought. There might be like some code comments, but the actual documentation that someone would go look might be very lacking. And so what this winds up happening is you get lapses in developers' trains of thought, and ideas and understandings that happen during development tend to get lost because, you know, documentation gets revisited potentially weeks later. Usually though, what also happens with this from a manager perspective is it's coupled with some sort of metrics to track progress, such as coverage testing, which is how much of your code is actively being tested. Now let's switch over to this idea of literate programming. Another term that this gets thrown in with is called exploratory programming. And the idea of this is we attempt to centralize our code, our testing, and our documentation into a single source. And so what happens is everything is developed at the same time. The benefit of this is we give our developers a sense of flow and purpose, because each idea is directly surrounded by that coding or that documentation in those tests. And so everything is just right there and centralized for them. And this is propelled even further through Sandbox coding environments such as Jupyter Notebooks, which many machine learning engineers are very familiar with, although currently they have a bad rap. My goal with this presentation is to turn this bad reputation into an understanding that if worked well, it can actually be quite successful. Now let's think about why this is important. I sort of mentioned some pretty cool parts in the beginning, but let's analyze it a little further. One of the things that we have directly seen at nbdev when integrating with nbdev, and specifically this literate programming environment, is you have faster training and pickup by your users of the software. By exploring each of these Jupyter notebooks, new users and teams are allowed to see where the original train of thought for this program was happening. They can sit there and play with the code and understand how all the parts flow together. It's no longer staring at source code, hoping there's a helpful documentation string attached with the file and having to bounce back and forth and find all the tests. Everything is just right there in front of them. And so as a result of that, you know, it in turn helps the readability of a project, because you don't have to sit there and split your mindset. Everything is laid out in front of you. And with Jupyter Notebooks, what that helps you to do is have a documentation focused mindset, which is one of the most important parts of working with Jupyter. very often Jupyter notebooks are seen sort of as one-off, and folks like to make blogs out of them. And so they're great for writing down your thoughts. And so what this allows is we can take these one-off thoughts and sort of this mindset of as you're coding and actually throw it somewhere and make it relevant for others to use. And it's no longer some insider knowledge that you didn't write down. Now, what sort of are these sandbox environments and how are they utilized today? And why is it probably not the best that it could be? So first, the definition of a sandbox environment. This would be what we would call an interactive platform where code is typed in and immediate feedback is received. So the code is compiled and exported and ran iteratively as needed. So on the left here, we have an example of me running a Jupyter notebook code cell where I have a Python comment saying this is an example print statement, followed by some Python code that says the sum of 1 and 2 is 3. And below, we have the printed output of that cell. If you're a data scientist or machine learning engineer, you're probably extensively familiar with this and tend to use Jupyter notebooks to build models very quickly and perform experiments. But that in turn leads to the second aspect of how these are commonly used. Usually Jupyter notebooks in the field currently sort of have this use and throw away mindset. So if I'm a typical data scientist, I'll quickly test my code in this Jupyter notebook, make sure the idea works, copy and paste that code into some arbitrary Python file, because that's really what the rest of the pipeline needs. I need the actual code, not this weird notebook. And so as a result, usually these don't get very intuitive names. A very common example is you have Untitled Notebook 470-24A Experiment 2. And so as a result, since these were kind of made with a throwaway mindset, 6 months down the road, you're not going to remember what that notebook did. You're going to find that random file and go, oh, I needed this 3 months ago. And this is a very common occurrence in the industry, and foresight isn't necessarily there because we don't come with that in mind, that use and throw away aspect that is the crux of development with these notebooks. How can we fix that? How can we turn this use and throw away mindset of, oh, this thing will never be useful for production, I'll just simply test here and then throw it somewhere useful? How do we turn that into an actual functioning development environment? Well, we need to rethink how we use Jupyter notebooks. Instead of having this throwaway mindset, we use that creative flow that I mentioned that these literate programming environments need. So as I mentioned before, we make sure the code tests and documentation are all in this environment. And what comes with that is we can still keep best practices of, say, test-driven development. That way we don't lose, say, the lessons that common software engineers learned along the way. And so what happens is we take the familiarity of the Jupyter notebook environment and couple it with these software practices to actually give you functional, well-documented, well-tested code that is almost indistinguishable as an end product from what, say, a professional and standard environment would look like. So on the right here, we have an example of what one of these Jupyter notebooks might look like. In a little bit, I'm going to go into more detail on how each of these little comment blocks are important, but you can see here that we have some documentation saying how we're going to have some simple functions that perform arithmetic. We have the source code here, and we have some tests that make sure adding 1 and 2 is 3, and adding -12 and 7 is 5. And this would be an example of what I would call a good Jupyter notebook written in the nbdev flow. Now, let's talk a little bit more on that. And how would we, say, integrate this idea of building this Jupyter notebook that can help us build software into something actually tangible, the software package? And that is through this concept and coding environment called nbdev, which I briefly mentioned before, but almost didn't tell at all. And the reason for that is, as we'll see shortly, it's a wonderful new technology that perpetuates this literate programming environment. We leverage that idea of exploratory programming through the Jupyter notebook, as we saw a moment ago, by having our code, our documentation, and our tests written in a single location. And on the right, we can actually see a diagram of what this looks like. So we start in our Jupyter notebook. When we push to GitHub, it can go ahead and run all of our tests. It can generate automatically our documentation and gives us our Python modules for our packages. And with no overhead from the user to actually do so. But first, let's talk about sort of what it looks like. I mentioned before there was those weird comment blocks in that source code. And these are what we would call tags. In nbdev, tags determine what type of content it is. So in the picture earlier, you saw me say default exp. This would be what we would want that exported Python file to be called. We have export, which I would wrap in a code cell, and this tells nbdev, I want this code to be thrown into that Python file. We have a hide, which allows us to tell nbdev, don't show this particular code cell in the documentation. This is very useful for, say, if you don't want to expose tests in the documentation to keep it quite clean without having to go through and store them separately. And then you can also have custom flag set. And what this allows you to do is have a separation of certain tests. So say I have tests that need to be run on the GPU and only run on the GPU. We can have a special flag for that, such as maybe CUDA, where we can explicitly tell nbdev run these tests with this flag. Some pictures of what this looks like can be seen below. So we have our default exp math. We have a hide, right? That hides our input from the documentation. And we have some source code defined, addition. Now, when we tell nbdev to build the library, this is what that Python file looks like. So it auto filled in essentially this dunder all, which is a helpful Python import for you to quickly grab the imports for all of this file. And on top of that, here's our source code, exactly how it was written before. And even further, this is what the auto-generated documentation winds up looking like. So we have addition, we have our inputs, and we have that doc string that we had before, all without me having to fill out a single markdown file or having to go through and write somewhere else. This is all centralized around that one Jupyter notebook. Now, I mentioned briefly earlier GitHub Actions and automating the running of our tests. But let's talk a little bit more about that. GitHub Actions, personally, I like to call your CI/CD best friend. If you work in GitHub, you should almost always have GitHub Actions. And what these allow us to do is through a single action, which is a set of directions, we can centralize test, deployment, and quality control automatically through any number of trigger points for GitHub. And this is because it's actually hooked through GitHub itself. So we can have events that say trigger whenever we push code to the Git repository. This would be something like running tests. Merging pull requests. This can again go run even more tests and ensure quality control. Or on software releases, we can have it automatically send new deployments, push our code to say Docker and build Docker images automatically and publish those. And so as you can see, like this has a lot of potential for utilization. And if you do leverage this well, it can get to the point where it acts as a second person, reviewing your code as you work and notifying you if, say, you forgot something. Because that is a very, very commonplace issue with software devs, especially on small projects where they don't have a huge industrialized workspace that does this quality control. This is set up for you from the very beginning. Now, how does nbdev leverage this? Because what I just mentioned, is what you can do with GitHub Actions. nbdev specifically has a few checks in place to make sure that a few quality control issues are met. One of them is to make sure that notebooks don't have any metadata thrown into them, and they're very what we would call clean. An example of why this is important is very commonly data scientists will quickly test in an environment called Google Collaboratory, which is a free Jupyter Notebook environment whose Jupyter Notebooks tend to have a bunch of extra little data thrown into each notebook as you download it, versus say something natively in Jupyter. And so as a result, usually reviewing these tends to be very rough because it has all that metadata. nbdev actually lets us remove that metadata entirely. And so as a result, these notebooks are very, as I mentioned before, clean. There's no added information, no matter what environment you use. Along with this, there are checks to make sure that source code and notebooks are aligned. So if you accidentally forgot to build the library, it will go ahead and alert you of this. So that way you know, oh, I didn't make this change, or I need to go see what's different. Along with this, on every commit, every single test in the notebook is run, part of that flag system I mentioned earlier. And so if there was a breaking change that say you forgot to test for, or you forgot to check for before you pushed, the CI/CD pipeline will automatically alert you that a breaking change happened. Now, at Novetta specifically, we've taken this further to have it check for our Docker deployments, test REST APIs, as well as provide aggressive version control for our software. And so, as I mentioned earlier, if you learn to utilize GitHub Actions extremely well, it is like a second developer, if not 3 developers at once, because of all of the checks and balances that can come along with it. Now, everything I just mentioned sounds extremely cool, extremely new tech and exciting, but where is it actually being used? Is it being used at all? And you might be surprised by the answer. FastAI, as I mentioned before, they are the inventors actually of nbdev, specifically Jeremy Howard. And so everything that comes out of FastAI nowadays has its foundations in nbdev. On our end at Novetta, AdaptNLP, which I'll talk about a little later, also utilizes nbdev, so we are using it at our company. Walk with FastAI was a lecture series I made for learning a deep learning framework that utilized nbdev to allow my students to have interactive code environments for them to learn this, while also teaching them how to perform basic software engineering as they go to become a empowered deep learning practitioner. And lately, we've even been seeing that nbdev is being thrown onto job proposals and job openings. More recently, in the last few months, I remember seeing a post by AMD where they were specifically looking for folks who know the nbdev framework. Now, I've obviously advertised nbdev can be a wonderful coding environment that can give you the power and knowledge to be confident in what you make sure that everything is tested, and provides helpful interactions for you as you go to make sure your quality control is up to date. But a lot of folks haven't really heard of nbdev. And the reason for that is, in its current state, it tends to struggle with the industry. And so for this next bit, we're going to talk about that, as well as potential solutions towards these problems that I myself and others I've spoken to have seen. Usually it can be broken down into 2 parts: setup issues and integration issues. On the setup issues front, one major drawback companies have to actually starting and using nbdev is existing projects have to be completely rebuilt with nbdev, because we have to take all of those source code and throw it into these Jupyter notebooks with the special formatting and make sure everything aligns. Without an automated tool, even a small library can take upwards of 20 hours to complete. And what comes with that is the documentation, in order for it to really be utilized well, has to be completely rewritten to match the nbdev framework if you want to maintain that exploratory fashion. And so that's a very large upkeep that a lot of companies just don't see the value in doing. On top of that, we then move to the integration issues, which there's about 3 major ones. First, testing in notebooks is pretty different than testing with standard frameworks like PyTest. There is no automated tool to go and collate your test outside into these notebooks. And so generally you have to make a decision of, do you either rewrite all your tests in these notebooks? Do you keep them external? and lose that aspect of the exploratory code style. This is a very important decision that companies would need to make. And on top of this, generally the code doesn't follow industry standards such as PEP 8. And the reason for this is efficiency versus industry. nbdev is there to empower you and help you build software libraries faster. And so what tends to come with that is aspects like one-line documentation strings where you get the gist of what's going on, but you rely on the rest of the documentation to get you there, rather than industry focus where we follow some standard formatting like PEP 8. It certainly can be done. There is nothing in nbdev that stops you from doing it, but usually to have that quick flow, you don't do it as much. And one of the biggest issues is reviewing Jupyter notebooks in GitHub for, say, a pull request where we want to integrate new code into our code repository is a complete mess. And there are some aspects that allow us to review it a bit easier, but when it scales in size, it tends to get a bit harder. I will make a note on this morning. GitLab specifically came out with a very interesting solution to this that seems to remove all of the Jupyter's aspects and just show you the source code. So that is an option for folks to look into if they use GitLab. But let's talk about 4 solutions to those problems. Lib to nbdev, a concept called documents in nbverbose, a library called nbagile, and then finally using nbdev and PyTest. So first, lib to nbdev. Lib to nbdev is a small library with a single purpose. Take an existing code base and turn it into an nbdev code base. This specifically came to me as a concept because we were trying to convert adapt-NLP to use nbdev. And I was sitting in there in those 20 hours of there has to be an easier way to do this. And so I wrote a very, very small library that performs that one task. But very quickly, we found that it was empowering other software developers to use nbdev, to a point where one even opened an issue in the repository and wrote a review of, I love that so much effort was put into something as a one-off. Converting a code base might be a one-off task, but doing it by hand is a put-off with the framework. Without this library, I wouldn't have even considered using nbdev. Now, just minutes after starting, I'm ready to bring the power of literate programming on my convoluted code base. And so without this tool, there would be that humongous barrier of adapting nbdev. And so this solves that first issue I mentioned earlier of how do we get industry users to try nbdev quickly. Next, we have the concept of documents and nbverbose. As I mentioned earlier, typically in nbdev, we aim for these one-line documentation strings. And so it usually limits on how we write out notation and documentation for our parameters. Documents in nbverbose accomplish this through documentation comments and directly work with nbdev. So let's talk about sort of what that looks like and why that's important. The code example you see here is what I would call, and a lot of people would call, a good documented function. So we have our parameters here, what it returns, followed by a documentation string with what this does, each parameter, its type, and some comment on what it does, what it's used for, and some documentation on what it returns, the sum of A and B. Now, the reason why documents, which was also built by Jeremy Howard, exist is Jeremy is very opinionated in how he writes his code, and one of the things he didn't like was having to write things twice. When you write things twice, you lose efficiency. And honestly, it gets annoying, especially whenever you have a function with a million parameters. And so how can we make that a bit more intuitive and efficient? Well, instead, we write our function like something on the left, where above each parameter, or right next to it depending, we write our documentation. So we say for A, which is an integer, it's the first number to add. B, which is an int and a float, it's the second number to add, which gets added to the first number. So you can see that we can have long documented strings for these functions without having to go in and repeat anything in our documentation string here. Now that's cool and all, the source code certainly doesn't look pretty, but what's the benefit? Now when we have that auto-generated documentation, it pulls this information we had here and throws it into our documentation itself. So we can see here that it has our parameters, A, integer, the first number to be added, B, it says it's optional, and it's the second number to be added. And then it got cut off here, but it will also tell you the return type, its annotation, as well as the documentation string for that. And so what this allows is taking this quick and efficient programming environment and making sure that we don't lose those good software practices, which is what we try and promote in the first place, and have clean, readable code. Now, lastly, we have nbagile, which this is another library that I'm working on that builds off of everything else that I mentioned before. And the goal of this is to take nbdev and prepare it for a true agile environment. Now, my vision for this project is automatically converting these doc strings, these document style doc strings, so what we have here, into something like NumPy versions, which is the long expanded docstring I showed you earlier, without having to have the user do anything. It's done automatically. Along with this, my vision is notebooks are an option rather than a requirement to sort of help address that GitHub issue with reviewing. So you can code in a Jupyter notebook, you have all of this, and then when you're ready, it goes and sends all of the documentation, the source code, and so forth to their proper places, and the Jupyter notebook disappears. And then when you're ready to go back and edit it some more, it gets rebuilt based on everything that we had before. And lastly, this might either come from nbagile itself, if not later in nbdev, support for non-Jekyll documentation sites, as currently that is all that nbdev supports. But many folks nowadays tend to use other documentation style formats, such as read the docs, which currently isn't supported. Now, an example of what I mean by this NumPy style documentation, which currently nbagile does, is we take this and the source code looks along the lines of something I showed earlier, where we have very cleanly the parameters, the types, the documentation for each of them, as well as return types, which this is what I would call good annotated source code. And lastly, I mentioned earlier nbdev and PyTest. Now, PyTest is a very standard Python testing environment that typical software engineers use. And it provides a lot of good tools for analyzing and testing the library, such as coverage tests, line by line, knowing what failed, and other very useful metrics for software engineers and managers to look at. Currently, there are integration solutions for nbdev and PyTest. So for example, we can actually, there is an extension that allows you to perform coverage testing. So you can see just how much quality control you have. But what I would love to see in the future is having cell-by-cell failures within these Jupyter notebooks, because currently it's built in such a way that we assume the first cell and the first patch of code that you wrote in the notebook is relied on by later ones. And so as a result, we come with the assumption of, if I can't run through the notebook in entirety, then I assume that whatever that failure point was affects everything else. In the future, I foresee that as not being as reliant, and so we can have those segmented out sections, and each can be independent of each other. And another likely helpful tool I could see happening is extracting all of our tests into a test folder. This is what PyTest uses, and this is typically what you see in industry coding projects, rather than having everything in a Jupyter notebook. And so what this allows is a healthy balance in total between these 3 and 4 solutions, a healthy balance of this exploratory concept and leveraging Jupyter notebooks while still maintaining what other typical software engineers would know, what they're used to, and what they learned. And then slowly over time, we might lean more towards one or the other, and that's okay. The goal of this is not to say this is the final solution. These are routes that we can take to come up with an intermediary to just get this in the industry. Now, I mentioned a lot of different options here, and I mentioned a lot of different setups. But what setup should you use today to have the best success at your company? Usually, and this is what you should do, you should have teams start with nbdev and learn the framework. It's a strong foundation, regardless of any of the additions and issues I mentioned earlier. Those are all solutions that, most of which are issues that have solutions right now. And so you should either start from scratch from using, say, a template repository that nbdev provides, or converting your existing library to nbdev with that lib2nbdev tool I mentioned earlier, and quickly have your team test out how they like nbdev. On top of that, if you find that standard documentation style and nbdev tends to be a little too cumbersome when it comes to writing those doc strings, go ahead and integrate documents would be the next step. So that way your team can efficiently write that clean, clear documentation for your parameters. But if that coding style is even a little too hard to navigate, keep an eye on NB Agile as I go through developing it. I imagine more will be coming from that project within the next few months. And so hopefully we'll reach closer to that goal of having the ability to just go ahead and use these in the Agile. Now I'd like to talk about how we use nbdev specifically at Novetta, because this is great and all, but I can actually provide for you a story of the journey that nbdev took at our company. Specifically through that adapt-NLP library, as I sort of hinted on earlier. So adapt-NLP's goal is an open source library for easy access to state-of-the-art models and practices in the language domain, such as named entity recognition or sentiment analysis. And about 9 months ago or so, I took over the project, and it was a standard Python project. But I had been using nbdev for quite a long time before that, long time being 6 to 9 months. And I wanted to use nbdev for it because I understood the benefits that it could provide. But after many hours of frustration, I wrote lib2nbdev because I did not enjoy the fact that I had to copy paste code. I knew there had to be a more efficient way. And after I converted this, it was very quick housekeeping to make sure that the documentation was fine, the library was cleaned up, and that tests were performed. And what we also saw was that the tests were actually lacking. And so we were able to quickly and directly see what was tested, what wasn't, and have all of that centralized, which improved the safety of our library as well, which was a side benefit. Some direct improvements we saw. New users and coworkers could quickly utilize the library and contribute to it, as it was very easy to learn and follow the flow of the development. Proper documentation was a forefront thought rather than an afterthought. And so as a result, we took the decision to write as many tutorials as possible as we were developing. And so yes, we did have, that sort of one Jupyter notebook open here, one Jupyter notebook there, but it still allowed for that exploratory documentation style that's really needed in this. And at first, teams were definitely hesitant to integrate with it because it is a very different coding process and train of thought for those who might not use Jupyter Notebook as much and still have that use and throw away mindset. But after learning the process, they found it extremely helpful and useful and helped them actually be faster at their coding because they had that ability to just work and be comfortable knowing that everything they do will be thrown into source code. Now, what is the future of nbdev though? Does it even have a future? Will it exist in 5 or 10 years? And where do I see it going? There's a rise in collaborative notebooks for viewing and specifically concurrently. And so where I see it going is we have teams building on nbdev built frameworks without tripping over each other and can have live feedback as they're going through these notebooks. We're already seeing the starts of this, but nbdev hasn't quite been thrown in there yet. So I'm very excited to see how nbdev or nbdev-like frameworks can help further this collaborative process. And as I sort of touched on a few moments throughout this presentation, I see notebooks as more of a means to an end to get thoughts on paper and then extracting that out into something more standard. We're seeing trickles of this in applications, though mostly it's manual. And I believe the main cause for this is that issue with just reviewing notebooks in GitHub. And that's where a lot of the hesitancy is, because as you get more and more notebooks and diffs, it tends to get really, really hard to go through and work with those to review. And so either we won't use notebooks at all in the review process, or the review process for notebooks will get better. And then I also see testing becoming more advanced, such as functions and applications that require multi-processing or multi-GPUs, which is extremely hard to accomplish in Jupyter, and for a while was a completely unsolved problem. And lastly, I see us getting some sort of clever reporting schema to give us feedback on library performance, such as when we run those tests, it gives us a reporting scheme of here's how that coverage looked, here's where some weak points are, and so forth. Next, that's basically the last of my presentation. I'm going to show you a demo of us converting a small library into nbdev and sort of the flow that comes along with it. Shouldn't take too long, should be about 10 minutes. So over here, I have a new repository I made, and I'll zoom in a little bit for folks to see, called ODSC demo. And if we look inside, it contains one file, arithmetic, which has a few math functions. Now let's start by turning this into nbdev. I already have the GitHub repository cloned here, but what I can do is use lib to nbdev to automatically convert our repo. So I can say convert lib inside our ODSC demo folder. And it's going to say, oh, you don't have a settings file. Let's make one. It wants a name for our library, so we'll just call this ODSC demo. This should match this folder, so this inside folder here of where everything is. Is this an enterprise GitHub repository? No. My username, a description, my demo. Some keywords, we'll say math, Python, nbdev. Some authors for it, so I'll say my name. An email contact. I'll use my work email. A copyright, and the main branch this project will be using, as well as a version. Before finally the minimum Python version, and then it should ask us for where we want the notebooks to be stored. So we'll say we'll make a notebooks folder to keep things separate. And it's going to automatically go through and convert our notebooks. And now it says it was fully converted. Before finally, 2 other options will be made. Do we want to set this project up to be pip installable? We will say yes or 1. And would we like to set up that automated GitHub workflow that nbdev provides, which we will also do. So now, if we look in here, we have a notebooks folder with arithmetic. And if I go and open it, after the kernel starts up for a moment, you'll find that it has all of our source code right here for us, as well as the file name. And so from here, I can go through and modify the documentation and say, oh, the title for this is arithmetic. and performs some basic math. And then below each of these, I can go through and add some tests, such as test, actually you can just do an assert statement. Addition 1, 2 equals 3, which might give an issue about that. And there's some tests automatically there for us. And now, since we've added a test, we can start using nbdev commands. Now, there are 3 that you should really care about. That is build lib, nbdev build lib, nbdev build docs, and nbdev test notebooks. Each of them are as intuitive as it sounds. So if I do nbdev build lib, it will go through and convert our arithmetic function, our arithmetic notebook, sorry, into that Python file, which you can see live in ODSC arithmetic. Next, we can do nbdev build docs, which will convert our arithmetic notebook into actual documentation. Might take just a moment. I know why that's an issue. And finally, we can do test notebooks, which it did not like that because we didn't install one. We always hope that demos will go well, but occasionally they don't. In any case, though, those 3 notebooks together will allow you, or those 3 commands will allow you to go through and make sure that things are tested, the library is up to date, and everything is pushed how it needs to be. So now that we have everything pushed how it needs to be, so you can see that we have, if we do git status, we added a make file, docs folder, nbdev settings set up along with a few other bits. I will go through and add the .github folder, and what this did was add this workflow that I mentioned I told us we wanted to do earlier. I can add a commit message, initialized the repository, and push to the main branch. Which now if we check here, we should see that it's updated everything. And we also have this workflow that will go through and test our code. Next, that sort of goes over how we first convert a repo and how we sort of adjust it to work with our library. Now let's talk about how we would actually go about deploying, say, the documentation. We use github-pages to host any project for free. And all we have to do to have this work is select the main branch to use and the docs and hit save. And after a few minutes, our documentation will be live at ODSC demo. Now, earlier we got a notice that I didn't include a index notebook. The index notebook, which is actually extremely important, becomes the essentially README for our repository. So I'll go ahead and quickly make one for us here. So we'll call this index.ipy notebook. We'll give it a title, my fancy title. This is a demo. I'll go ahead and rebuild the docs. It should take just a moment. Why could we not look at the index? Let's see if that helps. But what we should see now is, well, we won't have anything there. If we go over to arithmetic, here's that documentation. So we don't technically need an index, but it would be helpful to have. We can see here we have all of our parameters well documented for each of our functions. And if we hit source, it'll automatically pull the source code for each of those files. Now, there we go. Now that that's done, let's talk about nbverbose and documents, right? And show sort of what that looks like. And I'll try and keep this very brief with just that. And then afterwards, there will be some helpful documentation and links attached to show you how to do everything else. To use nbverbose, you just simply say from nbverbose.showdoc import star. And afterwards, I add documents. So I say first number to add, second number to add. And now I can do what's called showdoc, show the addition. And we'll see that it has our documentation strings for us here for the parameters. And that is fully how all of this works. In the chat here, I'm going to attach a few links for folks for relevancy to documentation for everything I mentioned before, but that's all I have. So now let's go ahead and open it up to questions.